Hello everyone. We are looking into geophysical logging methods. In the previous lecture, we had a look into electrical logging methods. We had seen many electrical logging methods. Then toward the end of it, we had a look into how we can estimate the porosity, water saturation, as well as permeability of the formations below the surface by making measurements of measurements using geophysical logging tool in a borehole. Then we had also seen how we can understand about the attitude of formations. That means within a borehole, whether the formations are horizontal or inclined, if they are inclined, at what angle they are inclined. That is what we had seen in the previous lecture. Today we will continue with the subsequent logging methods. The next logging method, which is also coming under electrical logging method, is known as induction logging method. So, induction logging method is equivalent to electromagnetic method, which we have seen previously, right? Surface electromagnetic methods we have seen, very similar to that. This using the same principle, we are going to carry out the work in the borehole. This method measures the electrical resistivity or conductivity in a open or PVC cased boreholes. Right? We had seen initially open well logging and cased well logging. The electromagnetic method can be carried out in a open well, that means well without completion, without any casing pipe, or we can also do logging in a PVC cased pipes, right. We can also carry out logging both above as well as below the water table. We can carry out the work. The electrical conductivity or resistivity, which we are going to measure by induction logging, is a function of, it is based on the type of the formation, its porosity, permeability, as well as conductance of the fluid that is occupying the pores. Hence, the induction log help us to understand about all this. Log is a function of specific conductance of pore fluids, right. Due to this reason, we are able to differentiate between zones which are occupied by water or oil. Right. We had also seen previously under electrical resistivity method. Right. Electrical resistivity of water is less, electrical resistivity of oil is comparatively higher. Making use of this, we were able to discriminate in the methods we had seen previously. The same is also possible here. Then we can also use this method to understand groundwater or subsurface contamination, especially by inorganics. Inorganic contamination can also be studied using induction logging. So, what is the principle of this logging method? The principle is the same. We had already seen this under surface electromagnetic methods. So, what we are going to do is, we are going to apply current through a coil, right. We are going to apply current through a coil, which is going to be lowered. So, this is the coil which you see here. When you apply current through this coil, it produces a changing magnetic field that is shown in the green color. It is something like, this is what we also call it as eddy current, right. This current, right, this field actually is leading to electromagnetic induction. This creates electrical current to flow in another wire loop which we have kept at the same place, right. That means we use two wire loops. One is to pass the current which produces a changing magnetic field. This field causes electromagnetic induction, which means electromagnetic induction results into a electrical current which is developed in another coil which we have kept, that generates some electrical current which is measured, right. So, the current measured is proportional to what we had already seen it. The current measured here in the meter is proportional to the nature of the formation, its porosity, and also the nature of the fluid that is occupying the pores. Hence, this is the advantage of induction logging. How are we carrying out induction logging? So, we had already seen there is going to be a high frequency current has to be transmitted. That means we need one coil to transmit current, that is here, right. So, it is actually in a sonde. Sonde is a watertight instrument that is lowered, that has to be lowered into a borehole. This is a borehole, right. So, in the borehole it is lowered, there is a transmitter coil which is a zoomed version of what you see within the borehole. So, this is the transmitter coil which creates alternative current which passes into the surroundings. So, this is the borehole. This transmitter which is at the bottom transmits current, right, which generates, right, magnetic field or magnetic induction. The generated magnetic induction creates a current in the receiver coil. So, receiver coil is kept at the top, right. This is a receiver coil. So, this is the region which got energized, right. This in turn produces some electrical current in the receiver coil. The current induced is dependent on the resistivity of the conductivity of the formation. Resistivity and conductivity of the formation depend on the nature of the formation, its porosity, and the fluid. The fluid which is occupying the porosity, right. So, these are the three major factors that control the resistivity or the conductivity of the formation, right. So, in induction log, we also call it as conductivity log, measures the formation's resistivity in boreholes drilled with non-conductive muds. That is one of the advantage. In the logging methods we had seen until now, starting from self-potential and resistance log such as normal, latero, guard, micro-resistivity logging methods which we have seen, and also dip meter log we have seen in the previous lecture. They all can be carried out in a borehole filled with conductive fluids, okay, because the current generated in the sonde has to pass into the formation. That is possible only through the drilling fluid which is in the borehole, right. Whereas here the drilling fluid need not be a conductive fluid, it can be even oil based drilling fluid, or the well need not have fluid at all. It can be with, this is the borehole, it can be just filled with air, the sonde can be lowered, air can be here too, right. Why? Because we are dependent on eddy current. So, there is no need for proper connectivity of the sonde with the surrounding formations at the sides of the borehole. Induction log, due to this reason, is actually easy to carry out, and there is practically no corrections need to be applied, right? Only in all the other logs, the manufacturers would have given some correction chart, and we also need to correct for invasion of mud, right? Using micro resistivity log results, we have to correct for invasion of mud. All these are not necessary for induction log. It is most widely used than other tools. Due to its simplicity, this method is very widely used. But always a combination of electrode and induction tools can be used to create single log of resistivity, right? This I have been keep telling, right? Never we depend on one particular geophysical method. So, when we talk about logging, when we do logging, we use almost all the logging tools. Especially with regard to electrical logging, we have already seen 4 different logging methods, right? Added to that is the 5th one, right? That is induction log. Combining all the 5, we can arrive at the resistivity variation of different zones in the borehole over which we have carried out logging. Okay. Then the electrode tools generally measure the shallow resistivity. Whatever we had seen until now, right, they measure the resistivity of a shallow zone, right. Here is a picture showing the depth of investigation. This is the borehole, right, this is the borehole. From the borehole, right, how much is the radius of measurement? So, we have already seen micro resistivity few centimeters, right, and lateral log is up to 1.5 meters, whereas induction log we can go up to 2.5 to 3 meters. So, further they had also has an advantage of, right, overcoming the effect of invaded zone, right. They are focused to minimize the effect of the borehole diameter, variation in borehole diameter, as well as the effect of invaded zone can be overcome. How we are going to see little later, right, how we are able to achieve this by tools consisting of multiple coil arrays, right. That means you will have a transmitter at the bottom and there are different receivers. Several receiver coils it will have. So, the tools will consist of multiple coil arrays, right. Why they are? They are designed to have better vertical resolution and depth of investigation. Okay. When this is the transmitter and this is the receiver coil, when you use this, shallow depth or radius is investigated, but what is in between these two we are testing. When you use the next one, you investigate a greater distance and understand the formation between these two. When you use this one, the radius of investigation increases and you try to understand collectively what is the effect of all these formations. Okay. So, that is the advantage. Though we have multiple receiver coils, at one time we will use only one, right. Maybe while lowering the soundwave we will use receiver 1, then when we lift receiver 2, then again we have to lower the tool, we will use receiver 3. So, this is how we progressively increase the radius of investigation. That is the advantage of this induction log. Commonly, though I have drawn many receivers, popular method is to have 3 focused logs called as deep, medium and short or shallow guard induction. These are the popular, most of the manufacturers produce sondes which are capable of measuring induction resistivity in these three configurations, right. That means it will have, the sonde will have three receivers, right. This is the, I am drawing the instrument which is the sonde. It will have a transmitter here at the bottom, then we will have a receiver 1, receiver 2, then receiver 3. So, this is short, medium and this is deep. So, this is the popular configuration, right. And the advantage of having these three focused resistivity reading can be used to determine the true formation resistivity, right, even if there is invasion of mud, right. What is invaded zone? We had seen initially, right. This is the borehole we are drilling. During drilling process, we have circulated the mud. The mud would have also invaded into the formation, right. The distance up to which it has invaded is known as invaded zone, right. The advantage of induction log is, though there is invasion, we are able to determine the true resistivity of the formation which is present beyond the invaded zone. How this is possible? We will use the deep focus, right. The deep one which goes up to 2.5 meters. Over there cannot be any effect of the drilling mud we had used. So, at the maximum, the drilling mud can enter into the formation to few tens of centimeters, right. So, the formation resistivity is very essential for us because we had already seen the method of estimating the porosity of the formation, right. How will you estimate the porosity of the formation? We need to have the resistivity of the formation, right. Resistivity of the formation with fluid is necessary. So, in order to have the true formation resistivity, we can use induction logs. This is necessary to calculate porosity, which we have learnt already, and also water saturation we had seen, right. So, over there we can use the formation resistivity derived from induction log, right. And how the resistivity is going to help us, right. For example, resistivity which we are going to get from the induction log will increase depending upon the grain size. The finest material such as clay will have a very less resistivity, whereas coarse grained formation such as gravel will have high resistivity. So, induction resistivity is related to grain size, right, and also it is related to the aquifer stratigraphy. It is also related to aquifer stratigraphy. What do we mean by aquifer stratigraphy? That means this is the ground surface, how the layers were present below the surface, where was clay, where was sand. That is also going to affect the resistivity which we are going to measure. Then resistivity measured is related to grain size. So, in fact, the grain size is also related to permeability. So, permeability is the ability of the formation to transmit water. Okay. So, there is an option for us to convert the resistivity which we have measured into permeability. This also we have seen already, right. Now, let us see how we can interpret the data. We had already seen there can be three focused logs as short, medium and deep. All these show similar response in very fine grained formations. Why they show similar response? Right? Here is an example log. Here is the lithological description. Here are the three logs. So, one is deep, medium, short. Short log is given by solid black line, then dotted line is for medium, deep is dashed line, right. Let us focus our attention to the log, right. Wherever all the three are together in this zone, here too, here too, here, right, and here too. Where else? Here. Wherever all the induction logs gave us the same resistivity given in ohm meters, right? Starting from here is 0.2, here is 2000. At wherever I have now drawn a red ellipse, at all these places, all the three logs, that is deep, medium and short, showed the same signal. They are nothing but shales. How are we saying this? Because they are they have to be watertight or very tight formations where water cannot enter. That is shale or clay. In shale or clay zones, during drilling process, the mud we have used cannot enter, right? Because it is already a compact. The hydraulic conductivity or permeability of clays and shales are very, very small, very less. So, drilling fluid cannot enter into the bore, enter into this shale formation. Due to this reason, whether you use short induction or medium induction or deep induction, you have the same response. Okay. So, very quickly we are able to interpret the log and find out the fine grain formation that can be differentiated from the coarse grain formation, right. Then the induction log tends to approximate the true resistivity of the formation. So, here whatever resistivity which we have got in this all the circled zones is the resistivity of the shale formation. Okay. Then when the three logs deflect to the right, here is another example. You can see deep, LD is deep, medium and then short given by S. When these three logs are deflecting, what does it indicate? It indicates the effect of drilling mud, invasion of mud into the borehole, right. So, when the mud has intruded, right, the deep log only will give the true resistivity of the formation. Look at the shallow and the medium, they are very much deflected, they have moved very much away from the other, indicating that the mud has invaded into these zones. Here the mud used would have been oil based mud, due to invasion of mud, the resistivity picked up by the short induction log is comparatively higher than the deep as well as medium. That itself indicates that the drilling mud used would have been oil based. Okay. So, this is how we are able to interpret. Similarly, on the previous diagram also you can see at these zones all the three are deflected, right. Similarly, here whenever there is some deflection, we can also infer the lithology. Whenever there is a deflection, certainly they are permeable formation. They must be either sand or sandstone. So, wherever you see, please, wherever there is a deflection, right, here too there is a deflection, that is a sandstone. Okay. So, whenever all the three logs are showing the same signal, they are indicating fine grained formation such as clays and shales. Whenever all the three deflect very much, when they are showing different signals, that indicates permeable zones, right? And also it shows us the invasion of drilling mud. The shallow gad obviously will be very much affected by the mud invasion, because mud can invade only up to few centimeters. The shallow log also measures the effect of the eddy current from shallow zone. So, it is very much affected. Shallow is here too, we can see shallow is very much deflected. Medium and deep are more or less together. That, what does it indicate? The mud invasion has not even gone up to the depth of investigation by medium induction log. So, this is how we are able to differentiate. So, further we are also able to differentiate coarse grain formation from the fine grain formation. Conglomerates, which are nothing but coarse grained, like pebbles, all of us have seen pebbles. Pebbles binded together is known as conglomerates. When these rocks are having oil, then they will have lower resistivity than sands due to lower irreducible water, right? What is irreducible water? The formation, after its formation is likely to be filled with water. Subsequently, beneath the surface, oil might have got generated. So, initially gas escapes, tries to push the water, then gas transforms into oil. Oil tries to push the water away, but in spite of the effort of oil, still the formation will have some amount of water, because the water cannot be squeezed out from everywhere, because water may be occupying some tiny pores, and also due to adhesion and surface tension forces, water cannot be completely pushed out by the force of oil. So, that component of water is known as irreducible water, right. So, conglomerates will have lower resistivity than that of sands, because in the case of conglomerates, which is very coarse grained, more water can be pushed out. Surface tension forces will be lesser in conglomerate than that of sand. In the case of sand, only sand will have more amount of irreducible water. Conglomerate will have less amount of irreducible water, due to which it will have lower resistivity. Oil saturation may have, conglomerate with oil saturation will have lower resistivity than sands, right, because sand will have comparatively higher amount of irreducible water, right. So, after having seen all the electrical logging methods, I would like to sum up the electrical resistivity logs which we have seen until now. We are able to quickly or very easily carry out the interpretation for identification of rock types. For example, just now we have seen very easily we are able to differentiate between shale, clay with the sand or sandstone. This is coarse grain, this is fine grain. We are able to differentiate them. We are able to determine the contacts between them. We are able to determine the thickness of the formation. We are also able to determine some aquifer parameters such as porosity, then permeability. We are able to determine this. We have already seen how we are able to determine porosity as well as permeability. Then it will also shed light on the quality of formation water. I didn't tell anything about that, right, but how we are able to understand, right. Suppose if the entire lithology is sand, let us assume this is the ground surface, everywhere we have sand. We are doing resistivity logging. Resistivity log in the sand part will be comparatively higher. When we meet the water table, let us say this is the water table, resistivity drops down at the water table, and resistivity will suddenly drop down to almost 0 when the water is saline. Here it is fresh groundwater, here it is saline groundwater. Okay, this is the resistivity. This is depth. Isn't it? It is quite obvious, right? When the formation water is contaminated, when it is contaminated, it has got more higher amount of total dissolved solids. So, due to which resistivity will be very, very less. Then we can also be able to determine water saturation. How much of pores is saturated with water, how much of it is saturated with oil. Hope you can recollect, we had seen one diagram showing water saturation and oil saturation, right. So, that is the greatest advantage of resistivity logging. And obviously, suppose if the hole is cased with metal casing, we cannot do resistivity logging. Very easily, the log will show the same value everywhere. So, we can suppose if it is an abandoned well, if we do not know up to what distance they have cased, we will be able to get that from resistivity logging. So, until now we have seen the various logging methods related to electrical. First we had seen cell potential logging, then we had a look into resistivity logging methods, right. That is, we had seen the various resistivity logging methods such as normal log. Under normal log we have seen two types, short normal and long normal. Then we had seen lateral log, then guard log, then we had a look into micro resistivity log, very different, some button cells. Then we had seen dip meter log, then today we had seen induction logging. So, we have seen the important electrical logging methods, and in this slide we have seen the broad uses of resistivity logging methods. Thank you very much.